Hi students, hope everyone is safe. Shall we start? So today's topic is factors and multiples. Okay. So there are two headings here, factors and multiples. So first we will see what are factors. Okay. So I'll just take an example of 12. Okay. We will just see which are the factors of 12. Okay. So for that, first we will see which all numbers when we multiply we are getting 12. Okay, we are going to find the factors of 12. So we will see. So as we all know, 1 into 12 is 12. Okay. Then 2 into 6 is 12. Okay. 3 into 4 is 12. Any other numbers when we multiply will we get 12? No, right? So 1 into 12, 12, 2 into 6, 12, 3 into 4, 12. So the factors of 12 are, just see, 1, that is this number, 2, 3, 4, 6 and 12. So, which are the factors of 12? The factors of 12 are 1, 2, 3, 4, 6 and 12. Okay, now we will have one more example. Number 14. Which are the factors of 14? So, you know 1 into 14 is 14 and 2 into 7 is 14. No other numbers when we multiply we get 14, right? So, which are the factors of 14? 1, 2, 7, 14. So, these are the factors of 14. So, what we can observe here, 12 was having 6 factors, whereas 14 is having 4 factors. So, it depends on the number. The number of factors depends on the number. So, in these two cases, what we can observe, 1 is a common factor. 1 is a factor of these two numbers, right? And also the number itself. See, 12 is a factor, 14 is a factor. So, what we can say, 1 and the number itself will always be a factor of that number, okay, and the rest will be depending on the number, okay. So, what are factors? Hope it's clear for everyone. Now, we will just go to what are multiples. Okay, now we will see the next subheading or next part of the heading, multiples. What are multiples? So, I have chosen the same number 12. So, see which are the multiples of 12. From the word multiple itself, something related with multiply, right? So, how are we going to write the multiples? Just multiply this number with 1, 2, 3, 4, all natural numbers. So, 12 into 1, 12, 12 into 2, 24, 12 into 3, 36, 12 into 4, 48, 12 into 5, 60, etc. So, here see the multiples of 9 also I have written here, 9, 9 2s are 18, 9 3s are 27, 9 4s are 36, etc. Then see multiples of 10, 10, 20, 30, 40, 50, etc. So, when we write the, you can see here dot dot I have given, that means that it is not ending, it goes on. 12 into 100, that is also a multiple. 12 into 1000, that is also a multiple. So, multiples are endless. You can write n number of multiples, but factors are limited. We have seen that the factors of 12 were only 6, but the multiples, as I have put the dot, there are n number of multiples. So, hope the idea of factors and multiples is clear for you. Now, see here, 4 into 5 is equal to 20. So, what can you say? 20 is a multiple of 4. I have told you 4 into any number, that becomes a multiple. So, 20 is a multiple of 4. Also, 20 is a multiple of 5. Same way you can say 4 is a factor of 20 and 5 is a factor of 20. So, hope you have understood the relation between the factors and multiples. Okay. Next, we have a heading, prime and composite numbers. Okay. So, I have written some factors of some of the numbers over here. Here, the factors of 2 are 1 and 2. The factors of 3 are 1 and 3. The factors of 5, 1 and 5. 7, 1, 7, 11, 1, 11. Whereas you can see the factors of 4 are 1, 2, 4. 6, 1, 2, 3, 6, 8, 1, 2, 4, 8, 9, 1, 3, 9, 10, 1, 2, 5, 10. These are the factors. So what difference can you observe? I have given two colors for that, one blue and one red. What is the difference that you can feel here? Yes, the thing is here we can see in this set there are only two factors. And the factors are very obvious. One is 1. One factor is 1 for every number, and the next factor is the number itself. Whereas in this case, we have extra factors. Here there is one extra factor 2, here extra factor 2 and 3, here extra factor 2, 4, here 3, here 2, 5, like that some extra factors are there. So we are grouping the numbers into two categories. One is the set of prime numbers and the set of composite numbers. So what are prime numbers? The numbers that have only two factors. The numbers that have only two factors, that is 1 and the number itself, are called prime numbers. The numbers that have only two factors. Whereas the numbers that have more than two factors, other than 1 and that number itself, you have some more factors here. So such numbers are in the group of composite numbers. Clear? So I have prepared the set of prime numbers for you. So here I have written the numbers up to 100 there. Okay. In this, the numbers which are shown in white color are the prime numbers, whereas the numbers that are shown in yellow color are the composite numbers. Okay. So, you know, we had discussed up to 10, 11 I think, right? So, 2, 3, 5, 7, 11 etc. are having only two factors, 1 and the number itself. Whereas all the numbers which are written in yellow color have more than two factors. Clear? Okay. You can notice one thing here. See, 1 is shown in a different color, right? What does it mean? Because 1 is neither prime nor composite. As we all know, 1 has only one factor, 1 itself. 1 doesn't have two factors. So 1 is neither prime nor composite. So hope you understood what are prime numbers and composite numbers. Now one more thing that I have to show you here. Here can you observe there are two prime numbers and in the middle one composite number comes. In very rare situations it comes. I will show you where it comes. So here you can see, just observe 3 and 5. See, two prime numbers are there and in the middle you have a composite number. So like that there are some other situations. See, 11 and 13 you can see, and in the middle you have a composite number. Whereas here 17, 19, see here also you have two prime numbers and a composite number comes in the middle. Again there are some cases here, see 41, 43, you have 42, a middle, a composite number is there. So we have a separate name for that, they are called twin primes. Okay, so what are two twin primes? Two prime numbers which have only one composite number in between are called twin primes. So see 3, 5, 5, 7, 11, 13, 17, 19, these are called twin. You know what I mean by twin? Twin means two, that's the meaning. So twin primes. So hope it's clear. Next one, prime factorization by factor tree method. So first of all, what do you mean by prime factorization? That is, prime factorization means the process of writing a composite number as a product of prime numbers. You got it? It's a process of writing a composite number as a product of prime numbers. I will show you how it is. See here, you know, 36 is a composite number. We all know that 36 is a composite number. Now here I have written factor tree. Tree means what you know. So I have made a tree like structure over here. So 36 is a composite number as we all know. So 36 I am going to write 36 as 2 into 18. Okay, 36 is equal to 2 into 18. Now 2 is a prime number, so you don't have to touch the 2, let the 2 be there. Now 18 is a composite number, so what I am going to do is I am going to write 18 as a product of two numbers like 2 into 9, 18. Okay, so now 2 also is a prime number, so keep it there. Now 9, how can I write? I can write it as 3 into 3, 9. Okay. So now see, 36 can be written as, 36 is a composite number. Now I have written 36 as 2 into 2 into 3 into 3. So when you multiply, you get 2 into 2, 4, 4 into 9, 36, same answer. So 36 as a composite number is written as a product of prime numbers. So by the method of factor tree. The same prime factorization can be done by another method that is called the division method. You know what is, how to do division, same method. So see, same number I have chosen, 36, see 36 I am going to do the division, okay. So division, while you do the division you have to use only prime numbers, that is something you have to note. So 2 is a prime number, so we have to start with 2, 2 into 18 gives you 36, then 18 you can divide again with 2, 2 9s are 18. Then 3, you can divide with 3, 3 3s are 9, then again 3 1s are 3. So this is how you do the division. So finally you can write 36 is equal to 2 into this, 2 into 2 into 3 into 3. Same answer you are getting, but we are using two different methods to write a composite number as a product of prime numbers. The first method was factor tree method and the second method is division method. You can use whichever method which is convenient for you, no matter. Now, highest common factor or HCF. So, from the word itself you can understand something we are connected with factors, right? And common, you know what is common? Common means same, isn't it? And highest, as obvious we know, biggest, that is the meaning. So, highest common factor, that's what we are going to find today. So, I have given an example here, HCF of 10 and 20 we are going to find. So, first I will write the factors of 10 and 20. We know how to find the factors of 10. 10, 1, 2, 5, 10. These are the factors of 10. And which are the factors of 20? 1, 20, 2, 4, 5, 20, 2 into 10, 20. So, these are the factors of 20. Okay. So, factors are ready. Now, tell me which are the common factors of, common means same factors. So, I will write the common factors here. Which are the common factors? You can see here 1 is a factor common, yes of course. 2 is a common factor, you can see 2 in both the cases. 5 is a common factor, yes 5 is same. 10 is also a common factor. So, I will write which are the common factors. 1, 2, 5, 10. These are the common factors. Now, out of these common factors, which is the highest one? Obviously, it is 10. So, the HCF of 10 and 20 is 10. So, you understood how to find the HCF. Very simple. First, you write the factors of both the numbers and then you find out which are the common ones and then find out the highest common factor. Now, the same HCF we can find by using prime factorization method also. We have already studied how to do the prime factorization. So, using that method, how to find the HCF, that is what we are going to learn now. So, first we have to make 10 as a product of prime numbers. So, that is what is called prime factorization. So, first I will write 10. Okay. So, we will use factor tree method. So, how can you make it as a tree? 2 into 5, 10. Okay. So, which are the prime factors there? 10 is equal to, 10 can be written as 2 into 5. So, I have written 10 as a product of prime numbers. Now, I will just take 20. I am going to make 20 as a product of prime numbers. So, see 20, 2 into 10. Then 10 is a composite number. So, I will just again divide it into 2 into 5. Okay. So, how can I write 20 now? 20 is equal to 2 into 5. 2 into 5. 2. See, I have just made a rearrangement here. I have written 5 here so that this 5 will come just above that for that. Okay. So, I have written 20 as 2 into 5, 10, 10 into 2, 20. Correct. So, now what you have to do? Tell me which is the common factors there, common to both 10 and 20. Yes, 2 is a common factor. As well as 5 is also a common factor. See? So, the HCF of 10 and 20 is equal to, you just from this common factor you choose 1, 2 into, from here you can choose 1, 5. So, 2, 5, 10. See? Before also we got the same answer as 10. So, this is another method of finding the HCF. So, still you got the same answer as 10. So, hope you understood how to find the HCF using two methods. One was just listing the factors, and out of that you find the common factors and then highest common factor you take. Here I have made it into prime factors, and out of the prime factors, which is a common one, I have taken out and I multiplied, that is the HCF. So, HCF is clear. Now we are going to deal with what is called LCM, or lowest common multiple. So, from this heading itself, it's something connected with multiples, okay. And as we know what you mean by common, we know, lowest also we know. Now, we will see how it is done. So, the question is find the LCM of 10 and 20. I have taken the same example so that it is easy for you to compare between HCF and LCM. So, 10 and 20. See, which are the multiples of 10? I have told you multiples means you have to just multiply it with 1, 2, 3, etc. So, 10 into 1, 10, 20, 30, 40, 50, 60, 70, and it goes on. Same way you have to write the multiples of 20 also, 20, 40, 60, 80, 100, etc. Now, tell me which are the common ones, common multiples. So, the common multiples are 20 is a common multiple, right? 20. Then, which is the next common multiple? Yes, 40 is there. 40 is common. Then, which is the next common multiple? 60 is a common multiple. See, we have written only up to here, so we have only this much. Actually, there are n number of common multiples. Okay. Out of these, which is the lowest one? Yes, of course, 20 is the lowest common multiple. So, LCM of 10 and 20 is 20. Finished. Okay. To find the LCM, also we have one more method, that is what is called the prime factorization method. Same procedure as we did in the case of HCF itself. So, first we will find out the prime factors of 10 and 20. So, this time we will choose which one? We will choose the division method. Last time we used the factor tree method, so this time we will use the division method. So, 10 and 20 we will find the prime factors, okay. So, first 2 5s are 10, 5 1s are 5. And how can you split this? 2 into 10, 20, 2 5s are 10, 5 1s are 5, okay. So, now we will arrange the numbers here. So, 20 I will write 20 is equal to 2 into 5, okay. Now, 10 I will write 10 is equal to 2 into, see only 5 is there. So, I will just write it below this 5, so that for us it is easy to circle the common ones. So, that is why I have written it just below 5. Done? Now, what you have to do, in the case of HCF, we had selected only the common ones, right? But in the case of LCM, you have to choose the extra number also, which doesn't have a common factor. Here, 2 doesn't have common something here, but no problem, you have to choose this also when you find the LCM. So, how will you write? LCM is equal to, out of this group, you have to select one, then from this group also you have to select, and from here also you should select 5. So, what is your final answer? 2 2s 4, 4 5s 20. So, we got the same answer 20 as LCM. So, we have found out how to find the LCM using prime factorization method. So, this whole class, what all things we discussed? First we found out what are factors, what are multiples, then we found out what are prime numbers, composite numbers, then you understood how to make them prime factors, prime factorization. There are two methods, one is factor tree method and one was division method, and then we found out how to find the HCF there are two methods, and then we found out how to find the LCM. For that also we have two methods. So hope you have understood the class. Thank you.